Hello. In this video, I will do examples of the concepts mentioned in section 2.4. So one of the most important concepts is the slope of a line, and a generalization of the slope of a line is the average rate of change. This is especially important if you get to calculus. So the average rate of change on some closed interval a comma b, it's f of b minus f of a over b minus a. So this is the formula for the average rate of change. So I'll do a couple of applications of that. This, by the way, on page 266. And I will do a couple of applications. So number 66 is on page 229. We are going to find and interpret the average rate of change illustrated in the graph. So we see this graph that represents the amount of money saved in dollars per month throughout 4 months. And we can pick any 2 points. So as long as we have any 2 points, we can find the average rate of change. Okay, so we have a couple of points. We can use the origin, and we have another point, which is to 100. So what do we have? We know that f of 0 is 0, and f of 2 is 100. So the average rate of change is going to be f of 2 minus f of 0 over 2 minus 0, where f of 2 is 100 and f of 0 is 0. So this is 100 minus 0 over 2. And 100 minus 0 is 100. So this is 100 over 2. And we can always simplify the fraction. So this is, we can see it this way. So that's $50 each month. So the interpretation is that a person saves $50 each month. During these 4 months. Next example. On the same page, number 70, we are going to use the average rate of change to answer the question. The total amount spent on plasma flat panel TVs in the United States changed from 5,302 million in 2006 to 1,709 million in 2013. Find and interpret the average rate of change in sales in millions of dollars per year, and run the answer to the nearest 100. That is to 2 decimal places. Okay, so we have 2 points. So we can see that it was 5,302 million in 2006, or 5.3 billion, and 1,709 million in 2003. So the average rate of change is going to be the change in sales in millions over the change in time. In this particular case, the sales declined. So they decline from 5302 to 1709. So this is 1,709 million minus 5,302 million over along 7 years. 2013 minus 200 minus 2006. Okay, so the numerator, 1,709 minus 5,302 is negative 3,593 over 7. And they're asking us to run to the nearest hundredth. So this is approximately negative 513.29 million per year. So conclusion, sales decrease by this amount per year. Or we could say on average, because it's not going to be, especially this type of data, it's not going to line perfectly on a straight line. So on average, sales decrease by 5,000 or 530 million or 500.13 million or 513.29 million per year. And the last application will be to cost, revenue, and profit. Okay, so we're going to read this in the book. Okay, so a linear cost function has the form C of x equals mx plus b, where x represents the number of items produced, m represents the cost per item, and b represents the fixed cost. The revenue function for selling a product depends on the price per item, p, and the number of items sold, x. And the profit is going to be the revenue minus the cost. So this is the application to revenue, cost, and profit. So this is cost, revenue, and profit. Okay, so the cost function is going to be C of x equals mx plus b, where m is the cost per item, and b is the fixed cost. So example of cost per item or variable symbol or examples of factors that affect them could be the cost of material, how much material you buy, how much electricity how much electricity you need to produce items. Those are examples. And fixed costs could be costs like employee salaries, rent costs, those type of things that you're going to pay no matter what, no matter how many items you produced. So that's the cost function. The revenue function is R of x equals P times X, where P is the selling price per item. And the profit is the revenue minus the cost. So we're going to go over number 78 on page 230. Or that's actually 232. Okay, so these are the directions. And we're going to do number 78. Okay, so this is what? This page 232. Okay, our firm will break even. That is no profit and no loss, as long as revenue just equals the cost. The value of X, where C of X equals R of X, or where the profit is zero, is the break-even point. Assume that each of the following can be expressed as a linear function. We are going to find the cost function, the revenue function, and the profit function, and we're going to find the break-even point and decide whether the product should be produced given the restrictions on sales. And I'm missing one part, what the columns mean. Okay, so there's that. Okay, so let's find the cost function. So the cost is going to be the fixed cost plus the variable cost times the number of items produced. So that's 2,700 plus 150, which is the cost for producing each item. The revenue function, so each item will be sold for $280. The revenue function is going to be R of X equals 280 times X. And the profit is going to be the revenue minus the cost. So each item will sell at $280, and they plan to sell X items. And the profit function is going to be the revenue minus the cost. So that's P of X equals R of X minus C of X. Okay, so this is 280X minus 2,700 minus or plus 150X. So distribute that minus, that is going to be 280X minus 2,700 minus 150X. And 280 minus 150 is going to be 130. Okay, so that's part C. Part D, find the break-even point and decide whether the product should be produced given the restrictions on sales. The restriction is that no more than 25 units can be sold. Okay, so the break-even point occurs when the revenue equals the cost. Where the revenue function is 280X, and the cost function is 2,700 plus 150. So that's a linear equation. We're going to subtract 150 from both sides or pass the 150 to the other side. So that's 130x equals 2,700, and x is, so divide both sides by 130 or pass the 130 to the other side dividing. And this is approximately 20.8. That's the break-even point. And there's one more part. So once we find the break-even point, decide whether the product should be produced given the restrictions on sales. Now, no more than 25 units can be sold. So it looks like it's going to be a lot of work, and the revenue won't be that good. So since no more than 25 units can be produced, the product should not be produced, or no more than 25 units can be sold. The product should not be produced. Here's the problem: the fixed costs are already 2,700, and the maximum profit. The maximum profit that they can make, it's only 550. That would be P of 25, which is 130 times 25 minus 2,700. At the end, that's only going to be 550. So if you have, if your fixed costs are 2,700, looks like it's not worth it. All the time and effort is not worth it. Okay, so this is what I wanted to show. Thank you for listening.